this problem right here. Here this question is asking condense the following expression into a single logarithm. So here we had to what we had to do is we had to just express the given logarithm into single form. Now let's see how to do that. First, what we can do is we can bring all these multiplication in front to the power log x power 3 minus log y power 5 plus 3 over 2, 2 over 3, 2 over 3 log of z. Actually, this 2 over 3 I can bring to the power. So, so this is going to be log z power 2 over 3. Now, the next thing what we can do is when in a logarithm, when we are subtracting, we are dividing. Like we can put it as dividing in the parenthesis. If you are adding, we can put it as multiplication in the parenthesis. Now here, what are the values with positive values? Those are the values that's going to be on top. So if I take log common, this x cube is positive because we have positive in front. So this is on the numerator, and then z power 2 over 3 also is going to be in the numerator, and then this y power 5 is going to be in the denominator. and that's our final answer. Condense the following expression into a single logarithm. We condense into a single logarithm. Now instead of z power 2 over 3, you can also write it as square root of, cube root of z square. Both of them are same. Okay, now let's look at the next problem. This is our next problem. Here it's asking expand the following logarithmic expression into a sum or difference of logs. This is opposite to what we did before. Before we just condensed. Here they have already condensed and we have to expand. Now let's see how to do that. So first what I'm going to do is I'm going to write these things like here we have cube root of ab square. Instead of cube root, we can also write it as a power 1 over 3. That way it's easy to expand. Now let's go ahead and write it in that format. So if we write it in that format, this is going to be a power 1 over 3, and this is going to be b power 2 over 3, and this c power 4 remains the same, and then power 5. And the power 5, we can bring it in front of the logarithm. So this is going to be 5 log a power 1 over 3, b power 2 over 3, and then c power 4. Now when we are multiplying, it's equal to adding. When we are dividing, it's equal to subtracting. So let's go ahead and do that now. So here 5, we have to take it as common, and then log. First we have a power 1 over 3, that's in the numerator. So we already put it as positive. We don't have to worry about anything. We have to just write a power 1 over 3. The next thing is b power 2 over 3. That's a multiplication. Therefore, this is plus sign. That is log b power 2 over 3. And then minus y minus because it's dividing. So we put a minus here, and then log c power 4. Now we can do one more thing. We can bring all this power to the front. So this is going to be 5 times 1 over 3 log a plus 2 over 3 log b minus 4 log 5. Log c. Okay. And that's our final answer. Let's look at the next one. Here's the question is asking, what is the domain of the logarithmic function shown below? To find the domain, you can go ahead and draw the graph, but you can do another thing here. When we have a log and we have a bracket, the value inside the bracket cannot be 0 or negative value. So log cannot be 0 inside of the parenthesis. This is not possible. And also log cannot have a negative value inside of this parenthesis. So these two conditions true for all the logarithmic equations. So here what we can do is, based on this information, what we can do is we can say 5 minus x is greater than 0, because it cannot be 0, it cannot be negative, so it should be greater than 0. So from this one we can actually, for this one we can subtract minus from both sides. I do it with a different color. So if you subtract 5 from both sides, okay, I put it as okay, minus 5 plus, like this, and then here minus 5. So we are subtracting, so this one cancels, and here we will have negative 5. So negative x, negative 5. Now to make this one positive, what do? I can divide both by negative 1. And when we divide by negative 1, the inequality will change. So this is going to become x is less than 5. So when we have a condition that x is less than 5, it means there's a hole at 5. So let's say this is 5. This is a hole. Hole means this point is not included, because if it's less than or equal to 5, it's included. If it's less than 5, it means it's not included. And the x value is going to have all the value in front of it, because it's less than 5, it means it's less than all the 5 values, like less than 5, but it can be 4, like all the values except it. So if we try domain, what is the lowest x value we can have? It goes to infinity. So negative infinity is the lowest value, and it goes up to 5, but it's not, 5 is not included. Therefore we put a round bracket right here. So negative infinity to 5. So the right answer here is B. Okay, so here you can see B and D looks the same. What's the difference? The D has a square bracket. Square bracket means the 5 is included, but here 5 is not included. So when we compare these two, like B is the accurate one because 5 is not included. So we have to put round bracket. That's why we select B. Now let's look at the next one. So here, what is the range of the exponential function shown below? Okay, so for this one, we had to actually draw the graph. So how to draw the graph? So whenever you have an exponential equation given, what you can do is you can look at the exponential associated with x. So here x minus 3. We have to equate this one to 0 and 1. We always do that for exponential function to find the graph. So x minus 3 is equal to 0, x minus 3 is equal to 1. Why do we do that? To find the point of interest. So when we solve for this one, x is going to be equal to 3, and here x is going to be equal to 3 plus 1, that is 4. So x is equal to 3 and x is equal to 4. This is our point of interest. We have to find the y value for these x values. So if I write xy table, we are going to have two values we have to find, 3 and 4. The y value at this x value. What is the y value at this x value? To find the y value, I can plug it in this equation. Let's use a different color. So for the first one, I plug 3. Y is equal to 2 power 3 minus 3 plus 1. 3 minus 3 is 0. So 2 power 0 plus 1. 2 power 0 is 1. 1 plus 1 is 2. So the answer for this one is 2. Let's plug 4 for this. So if I plug y is equal to 2 power 4 minus 3 plus 2, this is going to be 2 power 1 plus 2, that is 2 plus 2, that is 4. So the answer for this one is 4. Now we have enough information to draw the graph, but we also need to know the horizontal asymptote in order to draw the exponential function. Now horizontal asymptote is basically the addition of like when we have addition or subtracts, like when we have a constant added or subtracted, that's the horizontal asymptote. So here we have horizontal asymptote. If we don't have an addition or subtraction, the horizontal asymptote is 0. But here we have something, so it means this is the horizontal asymptote, that is y is equal to 1. So we have all the necessary information right now, so we can go ahead and draw the graph. Now, okay, wait a minute. Let me double check this one. You know what? Here I made a mistake. It's 2 plus 2 power this one plus 1. The equation is 2 power x minus 3 plus 1. I put 2 here. So that's a mistake. So this is 3. So the value here is 3. Okay. Now we can go ahead and draw the graph. I'm going to erase this thing. Okay, let's draw the graph. Let's say y-axis, x-axis, and the values we have. Okay, first let's go ahead and draw the horizontal asymptote. This is our horizontal asymptote. Horizontal asymptote is at y is equal to 1. So 1 here, and we are going to have a horizontal line like this. And we have to know that graph doesn't touch the horizontal asymptote. And let's look at the values we have found. So when x is equal to 3, y is equal to 2. This is 1 is horizontal asymptote, and 2, our first point is at 3, 2. So when x is equal to 3, y is 2. So this is the first point. The second point is when x is equal to 4, y is 3. When x is equal to 4, y is 3. The second point is right here. So you can see the graph is actually opening up in the, like it's going to our left, and the opening up in the left, going like this. Now what is the question here is what is the range? Range is possible y values. Now what is the possible y values for this? Range is basically the lowest y value it can have. Here the lowest value it can have is 1, but 1 is not included. So we put a round bracket. And it goes to the positive infinity in the y value as well. So it's go to positive infinity. Now let's look at the given answers. The first one is 1 positive infinity. The first one seems to be right, but let's check the others. 3 positive infinity wrong. Negative infinity 3 wrong. Negative infinity 1 wrong. So the answer is A. And that's it for this video, guys. Thanks for watching. See you guys on my next video.